Welcome back, dear students. Today we'll be continuing with polymer. Okay, and this is for class 12. So today we'll be diving. Our previous video we had discussed about a few important polymers. Today we will be going in more detail regarding other useful polymers. So today we will be discussing first about terylene or dacron. So here, let me tell you what you have to remember. You have to remember their monomeric units, and this is very important. Okay, you have to remember their monomeric units. From what these polymers, from which monomeric units they are obtained. So terylene or dacron is obtained from ethylene glycol, which is CH2OH, and benzene 1,4-dioic acid. So here benzene ring, and at one position and fourth position we have carboxylic acid. So whenever these two are reacted under 475 Kelvin, then what will happen? This molecule of water gets eliminated. Okay, OH from this side and H from here. So as a result, there is a bond formation between this oxygen and this carbon, and as a result, these two gets condensed. So as a result, we have a condensation reaction of these two. Okay, so here we get the polymeric form of this dacron. Now here you have to remember, like here, from here what has been eliminated? From this COOH part, OH is eliminated. Similarly, whenever it is bonded with other molecule, then OH from this path will be eliminated, and hydrogen from this path will be eliminated. That means another molecule of water. As a result, here see, as while writing the polymeric form, this H of this part is not written, and OH of this part is not written, because whenever it forms bond with other molecules, then those OH and H will get eliminated. Hope this is clear. Now let's move on to nylon 66. So nylon 66 we had discussed before also. So here nylon 66 we obtain it from hexamethylene diamine and adipic acid. So hexamethylene diamine and adipic acid, whenever it is heated under pressure, then we get what? The polymer of nylon 66. Here also the same molecule, like here NH2 is present. This H from here, this H and this OH will get eliminated as water. So as a result, here we have this bonding NH double bond O bonding, and from this side again, as in this case, whenever it has to form bond with other molecule, then this hydrogen of NH2 gets eliminated, and from this side this OH will get eliminated. So for remembering purpose, what you can do is a molecule of water is eliminated from here, and one hydrogen from here, and one OH from here. That means another molecule of water will be eliminated whenever you will write its polymeric form. Okay. So now let's move on to the next polymer, that's nylon 6. Remember this nylon 6. We have another polymer which is nylon 6. Okay, so please don't be confused regarding the numbers. In one case you have nylon 6, in another you have nylon 6 only. Nylon 6, number 3 is nylon 6 only. Now this nylon 6 we obtain it from caprolactam. So you have to remember the structure of caprolactam. Okay, it is a 7-membered ring, NH. Here you have double bond O. Then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. This is a separate member ring, and its name is what? Its name is caprolactam. Nylon 6 is also known as what? Purlone. P-E-R-L-O-N. Purlone. Now, whenever it is polymerized, polymerization takes place. Now, what happened? This bond here, this bond between this carbon containing C double bond O and this carbon gets broken. As a result, we have a chain form, no more ring form in the polymeric form. Therefore, we have, see, here we have C double bond O, this part, then we have NH. Then, how many carbons here? 1, 2, 3, 4, 5. We have 5 carbons remaining. That is CH2 whole 5. Now this is the polymeric. You can represent the bigger bracket CH2 whole 5. Okay, and here we have N number. So this N number of caprolactam, whenever it is polymerized, this bond breaks between this C double bond O and this carbon. And as a result, we have C double bond O, NH, then 1, 2, 3, 4, 5 carbons, that is CH2 whole 5 group. So this is the formula for Nylon 6. And please don't forget, its monomeric unit is what? Caprolactam. Now let's discuss about the next polymer, that is bakelite. So the next polymer is bakelite. Now here you have to remember the sequence of bonding here. Okay, the monomeric units of bakelite are phenol. Whenever phenol is treated with this formaldehyde, that is HCHO. And what will happen? A reaction will take place, as a result of which we get OH and this CH2OH at ortho position in one case, and the other product that we obtain is CH2OH group coming at para position. Okay, so here ortho position and para positions are occupied by CH2OH group and CH2OH group. Why? Because OH in the phenol ring is what? Ortho para directing group. Please remember this. Now, whenever these two molecules are polymerized, okay? Now let me write here. Now, whenever these two molecules are polymerized, then you get the complex structure. Polymerized. What do you get? You get a complex structure. And here, please remember this formula. What will happen? These molecules will come together to form cross-linked polymer. We have OH, and here again we have CH2 group. You have to remember the structure like that. And here again is CH2. Chain will continue. Here again you have this phenol group OH, and these two are linked by CH2 group. Please don't forget. And here the chain extends from this ortho position of OH. Okay? And this side again we have what? Here, don't be confused. Here again the chain extends from ortho position of OH. As in this case, this CH2 is at ortho position. Therefore, here also this chain will extend from ortho position. CH2. Again, you have benzene ring. CH2, and the chain keeps on two are given by CS2 group. And here the chain extends this side. Okay? Now please look at it. And here you have to remember all of them. They have OH group here. As in this case. Here OH group is present, and here also we have OH group. Now this chain keeps on extending in what? In all the directions. And we get what? We get the structure of backlight. And remember, this is a cross-linked backlight. Now this whole N, so here N number of phenol and N number of this formaldehyde was reacting to produce N molecule of orthosubstituted product and para-substituted product. Now when these two were polymerized, then we obtain the structure of backlight. Okay? Here. Now this is cross-linked backlight. This is the structure of cross-linked backlight. Now here, most important thing is you have to remember its monomer units prepared from phenol and formaldehyde. Okay? Now let's move on to the next polymer. That is, so let me check whether this is absolutely correct or not. This is COOH, OH. So chain extends this side. Here OH, OH, OH. The chain extends this side. So this two are linked by CS2. Now this is the structure which is given in your book. Okay? So now let's move on to the structure. The next polymer. The next polymer is melamine. So next polymer is melamine. Now in melamine, the monomeric units are, you have this structure, like in case of benzene. Now this 6 member ring are occupied. Now these positions are occupied by nitrogen, the alternate positions. And here in between we have NS2, NS2 and NS2 group. Okay? This is one of the monomeric units. And whenever it is reacted with formaldehyde, we have C double bond H and H. Then what we get? Now see, whenever these two are heated, then what will happen? At first, this carbon will be condensed with this nitrogen. Okay? So we have CS2O and one hydrogen will be coming here, from here. So as a result, what we get? So let me write this product. In fact, this is the intermediate. Okay? This is not the final polymer. This is the intermediate. Here we have NS2 group. Here NS2 group. And here now, as I told you, one of the hydrogen of NH2 will be replaced by this whole group, and we get NH, CS2, O, this CH2O, and that one hydrogen will be coming here to make it OH. Okay? Now this is intermediate. Very simple. This is intermediate. Intermediate product, that is resin intermediate. Now this, when further polymerized, what we obtain? We obtain, so see here, now similar to this, like here, one of the NH2 group was what? Substituted, this H of this NH2 group was substituted with CS2OH group. Similarly, this side also, and this side will also substituted, and the chain will extend in all the directions. Okay? So let me write that structure. We have this is structure. Here we have nitrogen, nitrogen, and nitrogen. Now here what will happen is we have all these three chains extending in all the three directions. So here what will happen? we get NH, NH, NH. Now this chain will continue. Now here we have NH2. Now NH and CH2. So here, now this contains CH2. Now this chain will continue. Zigzag means this chain will continue. Similarly here also the chain will continue. And this side also the chain will continue. Now this structure is the polymeric form of what? Melamine. Whole N. And this here, N number of them are reacting to produce the polymer. This you have to remember it. Okay? This is structure. And it's monomer units. Okay, now we will be discussing about biodegradable polymers. Now in your syllabus, you have two biodegradable polymers which we will be discussing now. Biodegradable polymers. Now, number one in your syllabus is what? PHBV. Okay, this is one of the polymer, and the monomeric units are this butyric. This is 3-hydroxybutanoic acid, 3-hydroxybutanoic acid. So let's start writing this structure. 1 carbon, CH2, CH. At 3 position, you have OH group, and here we have CH3. So 1, 2, 3, 4. So this is 3-hydroxybutanoic acid. So whenever 3-hydroxybutanoic acid is treated with 3-hydroxybutanoic acid. So one more carbon in this chain. So here we have COOH, CH2, CHOH, CH2, and CH3. So this is 3-hydroxybutanoic acid, and this is 1, 2, 3, 4, 5. At 3 position we have OH group. Therefore, this is also 3-hydroxy. Now 5 member group. Therefore, it is pentanoic acid. So when these two are treated, okay. Now whenever these two are treated, then what happens? The molecule of water gets eliminated. So here you have to remember this. H and this OH will get eliminated. So can we write them together? Now as this molecule of water is eliminated, similarly whenever it has to form a long chain, then this hydrogen will be eliminated and this OH from this side will be eliminated. Okay? So let me write its polymeric form. That means this side I'll be having oxygen, CH, CH3, CH2, C double bond O. You are left with C double bond O. Now this carbon is bonded with this oxygen. So oxygen, CH, CH2, CH3. Here we have CH2, COOH. So let me check. Now see this, as I told you, this C double bond OOH. This OH will be eliminated whenever it has to form the bond. Therefore, in writing the polymeric form, while writing the polymer, this will extend and you will have N molecules of this one. So here, don't forget, these are N number of molecules, and this is also N. Here I written here, okay? So whenever they are treated, what will happen? You get this product, and this product is PHBV. This is biodegradable biodegradable polymer. So here we have this structure. So let me take the structure of the product: OCH, CH3, CH2, C double bond O. Now this C double bond O is bonded with this oxygen. Okay, so CH, CH2, CO, CH2, CH2. So this is PHBV polymer. Now in your syllabus you have one more polymer, that is nylon 2, nylon 6. Okay, and this is also biodegradable polymer. So let's discuss about this. You have to remember, since this is mandatory, you have to remember the monomeric units. Every time the question is asked in IC. So next we are going to discuss about biodegradable polymer is nylon 6, nylon 2, nylon 6. So this is number 2 under biodegradable polymer, and it is nylon 2, nylon 6. Okay? So this is prepared from glycine. So we have already studied about amino acids. There we know the formula of glycine. It is NH2, CH2, COOH. It has both amino group and carboxylic acid. This carboxylic acid group. So this is the structure of glycine. Now, whenever glycine is treated with amino caproic acid, that is NH2 CH2 whole 5 COOH. This is glycine, and here this is amino caproic acid. So whenever these two are treated, now if you remember the monomeric units, the polymeric form you can easily write. You just have to eliminate some small amount of water molecule or other small groups. So here, by looking at it, you can also say what will be eliminated. OH group from here and a hydrogen from here. So here again, a molecule of water will be eliminated. So this NH2 can be written as NH. This water molecule will be eliminated, and as in other cases, whenever it has to form the bond, hydrogen from here will be eliminated, and OH from here will be eliminated. Therefore, N molecules of water will be eliminated. Here, you are treating with N number of molecules of glycine and N number of molecules of this amino caproic acid. While writing, you write the N in front of it. But here, I am writing it just above because here there is no space. Okay? So you have to write in front of it as here. So let me write the product. So here, hydrogen will be eliminated. So H, N, CH2, C double bond O. Now this C double bond O will be bonded with NH. Then we have CH2 whole 5, and here again we have C double bond O whole N. This OH and this H will be eliminated as a water molecule. You can remember in that way. Okay? So let me put the arrow in here only. So here this is the formula for nylon 2, nylon 6. Okay, so here we have NH, CH2, C double bond O, NH, CH2 whole 5, C double bond O, and the bond extends. The chain extends this side, and this is whole N. So with this we come to the end of polymer chapter. Now here, see, I have been telling you, you have to remember its monomeric unit, and one more thing you have to remember is, say, remember at least 2 to 3 uses of each of this polymer. So, hope this was helpful in understanding this chapter. So we'll be seeing you in next video. Till then, take care. Bye.